Dear children, once again welcome to our physics class. Hope you all are fine over there. Children, today we are discussing some of the numericals of this chapter, that is force and laws of motion. We have completed the theoretical aspect of this chapter. Now it's time to discuss some of the numericals based on this chapter. So listen carefully. Separate notes will be there, but I prefer taking down the notes along with that video lesson. Pause the video for a while, copy the question and try to solve the problem along with me. Okay, so let's get started with today's session. So children, let's discuss the numericals of chapter 5, laws of motion. So this is the first numerical. A 30 kg boulder was initially moving at a velocity of 10 meters per second. In order to stop it, 10 Newton of constant retarding forces applied on it. After how long will the boulder stop? So, what is given in the question? Let's write down the data given in the question first. Okay. So, mass of the boulder is given. And what is mass of the boulder? It is 30 kg. And it is moving with a velocity of 10 meters per second initially. So, initial velocity is given, that is 10 meters per second. In order to stop it, 10 Newton of constant retarding force is applied. So actually it's a retarding force, so it is 10 Newton. And after how long will the boulder stop? So you must find out the time. Okay, so M is given and force is given. Initial velocity U is given and you must find out the time. So time can be found out using the equation V is equal to U plus AT. This is the first equation of motion. Okay. And from this, what is time? Time is equal to V minus U by A. That is time. So, in order to find out the time, we require final velocity V, initial velocity U, and the acceleration A. So, initial velocity is given in the question. It is 10 meters per second. Final velocity is also given. In order to stop it, so finally we need to stop the boulder. So if finally when the boulder stops, its velocity will be 0. So the final velocity V is 0. Then we need to find out acceleration. So how will you find out acceleration? See, in order to find out acceleration, we must use the equation of force. So the force is given, which provides a clue to find out acceleration. We know that force F is equal to ma, isn't it? So, from that, A is equal to F divided by M. And F is given, it is 10 divided by mass. Mass is given, it is 30. So, acceleration is 10 by 30. So, we can substitute here. Velocity V is 0 minus initial velocity is 10 divided by acceleration is 10 divided by 30. And again one more thing, this is a retarding force. So retarding force will have a negative sign. So F is minus 10 Newton. So here acceleration is minus F by M. And again here minus 10 by 30. Minus 10 by 30 will be minus 1 by 3, isn't it? So we can write equal to minus 10 into minus 3, because when you take the reciprocal of this 1 by 3, minus 1 by 3, you will get minus 3 equal to 30. Then unit of time is seconds. So after how long will the boulder stop? Boulder will stop after 30 seconds. Okay. So children, if you want, you can pause the video for a while and note down the question, and you can do the problems along with me. Okay. Separate notes will be there, but it's better not to trust or depend upon the notes. You can copy the question and you can do the problem along with me. What is the next question? A ball of mass 5 kg experiences a change in its velocity from 2 meters per second to 4 meters per second within 20 seconds under the influence of a constant force. So, however, the direction of the ball is moving, it does not change. And find the direction and magnitude of this force. Okay, So mass is given, mass of the ball is 5 kg and its velocity changes from 2 meter to 4 meter per second within 20 seconds. So initial velocity is 2, final velocity is 4 and time is 20 seconds. Okay. Of course, here unit will be the initial velocity 2 meter per second, final velocity 4 meter per second. Okay. Now, however, the direction of the ball does not change. If direction does not change, that means it moves along the same direction. Only the magnitude will change. So, find the direction and magnitude of this force. So, how will you find out the direction and magnitude of this force? How will you find out force? Force is equal to mass into acceleration. That is equal to m into, what is the equation to find out acceleration? V minus u by t. This is our second equation of motion. Newton's second law of motion, not equation. This is Newton's second law of motion. F is equal to ma and where a is v minus u by t. Now substitute. F is equal to m. What is m? 5 into v is 4, u is 2 divided by 20. So you will get 5 into 4 minus 2, 2 by 4 minus 2 is 2, 2 by 20 equal to 5 4s are 20, then you will get 1 by 2 and 1 by 2 is 0.5 Newton. So this is the force, this is the magnitude of force. And what is the direction of the force? This force will be acting along the direction of motion because the direction of the ball is not changing, it is moving along the same direction, straight line. So the force will be acting along the direction of motion. Okay. So the direction is along the direction of motion and magnitude of the force is 0.5 Newton. Now, this is the third numerical. A 10 kg body is under the influence of two perpendicular forces of 6 Newton and 8 Newton. What is the direction and magnitude of the acceleration in it? So here mass of the body is given. Mass of the body is 10 kilogram and two perpendicular forces are given. That means if one force is acting along this direction, suppose this is the first force 6 Newton, then another force will be acting in the perpendicular direction like this, 8 Newton. Okay, so what is the direction and magnitude of acceleration in it? So a 10 kg body, suppose this is our 10 kg body. Okay, this is our 10 kg body and a 6 Newton force is acting on the body in this direction. Suppose this is the force and 8 Newton force is acting on the body in this direction, in the perpendicular direction. So what is the direction and magnitude of the acceleration in it? So first we need to find out the resultant force acting on the object. Actually two forces are acting on the object. One is 6 Newton and another is 8 Newton. And these two forces are acting in the perpendicular direction. So what will be the net force or the resultant force due to these two forces? And you know force is a vector. So whenever two vectors are acting in the perpendicular directions, we can find out the resultant force using this expression. That means the F resultant is equal to square root of F1 square plus F2 square. Like this you can find out the magnitude of resultant force when two vectors are acting in the different directions, and equal to square root of, what is the first force? 6 square plus second force is 8 square. So we will get square root of 36 plus 8 square is 64. That is square root of 100. Square root of 100 is 10. So 10 Newton is the resultant force. You got the force. Then what will be the acceleration? Once you get the force, you can find out acceleration using the equation. Acceleration is equal to F by m. And here you need to consider the resultant force. And what is the resultant force? It is 10 Newton divided by mass. Mass is again 10. So acceleration is 1 meter per second square. Okay, so this is the magnitude of acceleration acting on that 10 kg body. Okay, so next numerical is a lady of mass 80 kg stands on a weighing machine inside an elevator. Find the readings of the weighing machine when the lift moves up at a constant speed of 8 meters per second, when the lift goes down at a constant acceleration of 4 meters per second square, when the lift moves up with a constant acceleration of 4 meters per second square, and when the wires holding the lift break, causing the lift to crash down. Okay, so this is a very interesting problem, my dear children. Here there is a lady, and that lady has got a mass of 80 kg, and she is standing on a weighing machine inside an elevator. Elevator means our lift. So suppose this is our elevator, and inside the elevator weighing machine is kept, and our lady is standing on this weighing machine. Okay, now mass of that lady is 80 kg, and the two forces acting on this lady will be the weight of the lady mg acting vertically downwards, and the normal reaction N or R acting on the lady, which is offered by the weighing machine on that lady. So normal reaction is the force exerted by the weighing machine on that lady. So these are the two forces acting on the lady in an elevator. And in the first case, the lift moves up at a constant speed of 8 meters per second. So speed is constant. When speed is constant, there won't be any acceleration. Okay, so if there is no any acceleration, that means in the absence of external force, these two forces will be balanced. That is, the normal reaction R will be equal to mg. And for this problem, we can take the value of g as 10 meters per second square for our convenience. Okay, so you will get the normal reaction R is equal to mg, and from this you will get R is equal to mass. What is mass? Mass of the lady is 80 into G is 10, so you will get 800 Newton. This is the normal reaction force. Then what will be the mass of the lady? We need to find out the readings in the weighing machine, and weighing machine gives us the weight, and Newton is the force, it is not the weight. So how will you find out the weight? You can find out the weight by dividing force by G. Okay, and here G is 10, so the weight will be 80 kilogram. Okay, so this will be our weight, 80 kilogram. Next, let's discuss the second case. The lift goes down at a constant acceleration of 4 meters per second square. So now the lift goes down, and what is the acceleration? Acceleration is 4 meters per second square. Again, the normal reaction force and mg is still there. So what will be the equation of motion? Here the equation of motion can be written as, see here, lift goes down. So which force will be dominating? So lift goes down means lift is moving along the direction of mg, because mg is acting downwards. So mg will be dominating, lift goes down, mg minus reaction forces R, because the net force acting along the vertical direction will be mg minus R. mg and R is acting in the opposite direction. So when we add these two forces or combine these two forces, we can write mg minus R. mg will dominate, and even if we add it, we will get R itself. Why? Because mg plus of minus R is mg minus R itself, equal to force. What is the external force? The external force is acting in the downward direction, and that is MA. Okay, so what will be the reaction force? So from this we can write mg minus MA equal to R. Okay, so therefore R equal to M into G minus A equal to M. What is M? Mass is 80 into G is 10, and our acceleration is 4. 10 minus 4 is 6. 6 into 80 will be 480. So the normal reaction force will be 480 Newton. and from this what will be the weight of that lady or mass of that lady? It will be 480 divided by 10. 480 divided by 10 is 48. So 48 kg is the weight of that lady when the lift goes down at a constant acceleration of 4 meter per second square. Okay. Now, what is the third case? When the lift moves up with a constant acceleration of 4 meter per second square. So now the lift moves up with the same acceleration of 4 meter per second square. Now what will be the equation of motion? So here lift moves up, so the lift moves along the direction of R, so R will dominate, and the total force acting along the vertical direction is R minus mg. R will dominate, so we can write R minus mg equal to force. This is the net force. R minus mg is the net force acting in this direction, and we know the equation for net force as per Newton's second equation is ma. So instead of F we can substitute ma. That's why ma is written here. Okay. Now from this, what is R? R is equal to m into ma plus mg, that is equal to m into a plus g. Okay. And equal to, what is m? 80, and acceleration is 4, g is 10, so 14. 10 plus 4 is 14, and 14 into 8. What is 14 into 8? So what is the weight? Now the weight, the normal reaction force is 1120 Newton. And what will be the weight of that lady in the weighing machine? You will get the reading in the weighing machine by dividing this normal reaction force with G. So you will get 112 by G. G is 10. So what is the weight? 112 kg. So when the lift moves up with a constant acceleration of 4 meter per second square, weight of the lady is 112 kilogram as weighed by the weighing machine. It is not the actual weight. Okay. Now let's discuss the fourth case. The wires holding the lift break, causing the lift to crash down. So now the lift crashed down. That means the lift falls freely. It will be a free fall now. So whenever the fall is a free fall, lift is going down with an acceleration of g. So what will be the equation of motion? Our equation of motion will be mg minus r. Since it is a downward motion, mg will dominate. Mg minus r equal to f. And what is that f? Here f cannot be written as ma because this f will be mg itself. Since it is a free fall, the acceleration in this a force will be replaced by g. So you will get R is equal to, from this equation, R is equal to mg minus mg, that is 0. So the weight of that lady as weighed by the weighing machine will be 0 kg in the fourth case. And you know, whenever an object is in free fall, it will experience a sense of weightlessness. That means the weight is 0. Okay, so these are the different cases of an elevator, and you must remember this 4 different cases. Okay. 2 masses of 10 kg and 20 kg are hung from the ends of an inextensible string which goes over a frictionless pulley. Find the acceleration in the masses and the tension in the string when the masses are released. So 2 masses are given here. One is 10 kg and another is 20 kg. And what are the forces acting on these masses? One is the weight of the mass. So let the weight of first mass be m1g acting vertically downwards, and the another force is the tension of the string acting upwards. And for the second mass also, the weight m2g acting vertically downwards, and also the tension of the string acting along the upward direction. And this mass, 10 kg mass, moves in the upward direction. So the 20 kg mass comes in the downward direction. So here acceleration is along the upward direction, and for the second mass acceleration is in the downward direction. Now similarly, like in the previous problem, we can write the equations of motion for mass 1 and mass 2. So for the first mass, how will you write the equation of motion? First mass goes upward, that means along the direction of tension. So we can write the net force is tension minus m1g equal to, it is the net force, and the net force can be written as ma. Okay, that means, to be more specific, it is m1 into a. So we can write T minus m1g equal to m1 into a. Let this be our equation 1. Similarly, form the equations of motion for second mass. So second mass 20 kg moves downward. So it is moving along the direction of m2g. So m2g will dominate. So we can write the net force acting on the mass is m2g minus tension, because both are acting in the opposite direction, and that will be the net force, and the net force is m2 into a. So let this be our second equation of motion, and we need to solve this equation. So for that, just add equation 1 with 2. So whenever you add equation 1 with 2, you will get T minus m1g plus m2g minus t. So plus t and minus t will cancel, and we are left with minus m1g plus m2g equal to, then add the RHS part. RHS part is m1a plus m2a. Okay, now here g is the common factor on the LHS side, so we can write g into m2 minus m1. m2 minus m1 equal to a into m1 plus m2. So we need to find out acceleration here. Find the acceleration, isn't it? So what is acceleration? Acceleration is equal to g into m2 minus m1 divided by m1 plus m2. Okay, divided by m1 plus m2 equal to, what is g? The value of g can be taken as 10 for our convenience, into m2 minus m1. m2 is 20 and m1 is 10. So 20 minus 10 is 10, divided by m1 plus m2. 10 plus 20 is 30. So we will get 100 by 30, and 100 by 30, when you simplify 100 by 30, you will get 3.33. So what is the value of acceleration? Acceleration value is 3.33 meter per second square. Okay, meter per second square, that is the value of acceleration. And you must also find out the tension in the string. So whenever you substitute the value of A in any one of the equation, in equation 1 or equation 2, you will get the value of tension. Okay, so let me do that. So we got the value of acceleration as A equal to 3.33 meter per second square. And what is the first equation of motion? First equation of motion was T minus m1g is equal to m1 into A. Okay, so what will be T? Therefore T equal to m1 A plus m1 g, that is equal to m1 into A plus g, that is equal to m1 is 10 into A is 3.33 plus g can be taken as 10. So whenever you simplify, you will get the value of tension as 133.4. Tension is a force, so its unit is Newton. 133.4 Newton is the answer. Okay. And now let's discuss the next numerical. 20.02 kg caroms moving towards each other at 5 meter per second collide and rebound at the same speed. Calculate the impulse imparted to each carom because of the other. So two caroms are there, and each of the caroms are moving towards opposite direction. Mass of each carom is same, that is 0.02. And the first carom is moving, both the caroms are moving towards each other with the same velocity, that means 5 meter per second. So let this velocity is taken as positive because it is along the positive x direction, and let this velocity is taken as negative because it is moving along the negative x direction. And when these two caroms approach each other, after some time they will collide, and after collision, because they come towards each other, so after some time they will collide, and after collision they will rebound. That means this carom again moves in the opposite direction and the second carom moves in the opposite direction. Rebound means they will rebounds with the same velocity. So now the velocity of this carom, that means let this be our first one, let this be our second one. Here also let this be our first carom, let this be our second carom, and let this be the initial velocity of first carom, and let this be the initial velocity of the second carom, because this is the case before collision. And after collision both the caroms rebounds with the same speed. So now this first carom moves along the negative x direction, so its velocity, final velocity, can be taken as v1, and it is minus 5 meter per second because the magnitude of velocity does not change. It is given in the question, rebound at the same speed, that means only direction changes, and the second carom moves with a velocity of 5 meter per second now. Why? Because second carom is now moving along the positive x direction. So the velocity will not change, but the speed of the carom will not change, but the direction of the caroms will change after collision. Now we need to find out impulse, and impulse is found out using this equation. Impulse is equal to change in momentum. Okay, change in momentum, that is impulse. So for the first carom, what will be the impulse? For the first carom, impulse will be change in momentum, that means final momentum minus initial momentum. So for the first carom, what is the final momentum? This is the first carom, and the final momentum is m1 into v1. m1 v1 minus initial momentum of that first carom is m1 u1 equal to, mass will be the same, so m1 is same, so we can write m1 into v1 minus u1, isn't it? And that is equal to, what is m1? m1 is 0.02 into v1 minus u1. What is v1? v1 is minus 5 and u1 is 5. So v1 minus u1 will be minus 5 minus 5. That is minus 5 will be minus 10, and minus 10 into 0.02, that is equal to 0.2 minus 0.2 kilogram meter per second square. So this is the impulse for the first carom, minus 0.2 kilogram meter per second square. That is the impulse for the first carom. Now let's calculate the impulse for the second carom. So impulse for the second carom is again change in momentum, that means final momentum minus initial momentum. So what is the final momentum for the second carom? Final momentum is m2v2 minus initial momentum is m2u2, that is equal to m2 into v2 minus u2 equal to, mass will be same, 0.02 into v2 is 5 meter per second minus u2 is minus 5, so minus 5. So you will get 0.02 into 5, minus of minus 5 is 5 plus 5, 5 plus 5 is 10, so 10 into 0.02, again it is 0.2 kilogram meter per second square. So impulse for the second carom is 0.2 kilogram meter per second square, and impulse of the first carom was minus 0.2 kilogram meter per second square. See, so the impulse of one carom on another carom will be acting in the opposite direction. Okay, so the first carom will impart impulse in this direction, and the second carom will impart impulse in the opposite direction. Okay children, so this is the impulse. Way to find out the impulse. Now this is the homework for you. A missile of mass 2 kg is fired from a bazooka. That means it will be, you know, how from where the bazooka is that a missile is fired. So given that the muzzle speed of the missile is 40 meters per second, calculate the recoil speed of the gun. So try to solve this problem and try to solve this problem by yourself. Okay. With this, I am concluding my session. Notes of the topic and YouTube video have been uploaded. Just go through it. With this, I am concluding my session. Notes of the topic has been uploaded. Please go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.